My name is David Fakuju, aka Prof.T. As you know, we are here again. Tonight, I want to teach about chemical equilibrium, the factors that affect chemical equilibrium. We have three factors. We have temperature, we have pressure, and we have concentration. Now, the factors, how do you know which of this is going to happen? What is the chemical equilibrium? Chemical equilibrium is a reaction in which the forward reaction and the reverse reaction is what? Is at equilibrium, which means the rate of reactions, the forward reaction and the reverse reaction is equal. But in chemical equilibrium, we have a principle that we use to address the effects of these three factors on chemical equilibrium. The principle is Le Chatelier's principle. We state that in a chemical equilibrium reaction, when the reaction is at equilibrium, if any of these factors disturb the equilibrium, Le Chatelier's principle will act in opposite to the disturbance, which means if there is increase in temperature, for instance, Le Chatelier's principle will act to favor the reaction that decrease the temperature. And the same thing with pressure. If there is increase in pressure, Le Chatelier's principle will act in opposite to favor the reaction that will decrease the pressure. The same thing to concentration. For instance, there is a sign that we use to know these factors. The first one, in temperature, if change in temperature, for instance, we call it change in heat, is less than 0, it means there is no heat in the system. And if there is no heat in the system, it means it's what? It's an exothermic reaction. Exothermic reaction, if there is no heat in the system. So if this reaction, by the way, it must be a balanced reaction. If this reaction is an exothermic reaction, which means the forward reaction is exothermic, if this sign is in front, like this, it means the reverse reaction will be endothermic. So if the forward reaction is endo, if the forward reaction is endo, for sure, the reverse reaction will be exo. If the forward is endothermic, the reverse will be exothermic reaction. And that is it. And if it's endo, it means increase in temperature if is the disturbance favors endothermic reaction. Increase in temperature favors endothermic reaction. And if endothermic reaction is favored, which means if there is an increase in temperature of this system, we already said that increase in temperature of endothermic reaction, and the forward reaction is endothermic, it means that there will be exo. Exo will be favored in order to what? To decrease the temperature. And if increased temperature favors endothermic reaction, then what will happen? Le Chatelier's principle will favor the reaction that will decrease the temperature. And that is exothermic reaction. Are you with me? Because if increase favors endothermic reaction, that means decrease in temperature will favor exothermic reaction. So there is increased temperature of the system, automatically Le Chatelier's principle will favor the reaction which is exothermic reaction. That means exothermic reaction which is a reverse reaction, and reverse reaction, that means reverse reaction will be favored, which means the reverse reaction will be favored. In this case, reverse reaction is favored in this reaction. And if reverse reaction is favored, what happens? There will be increase in 2SO2 because this one is favored, which means this becomes a reactant for the reverse reaction, and this becomes the product, which means there will be addition of or increase in mole or in volume. Increase in mole of 2SO2 and O2. That is temperature as a factor. That is what will happen. Now, if it's a pressure that is our factor, what will happen? If it's a pressure, what will happen? Let's check that in the next video. Thank you.